All right, guys, what's up? So the second part of Unit 2 are the acceleration and the graphs. So it'll make sense. So we talked about displacement, we talked about distance, we talked about velocity, we talked about speed. Speed is scalar in nature, just a magnitude, just a number. Velocity is a vector in nature. It's got a number, a magnitude, and it's also got a direction with it. So we're going to start to see that now when we look at the graphs and when we look at acceleration. Um, those things will start to make sense. So acceleration is the rate at which velocity changes. So it can be the number that changes, it can be the direction it changes. So acceleration can result from a change in speed, either increasing or decreasing, a change in direction, either back, forth, up, down, left, right, doesn't matter, or both. It could be changes in both as well. So you need to make sure that you know that just because the number may stay the same, like you could be traveling 10 meters per second north, but then all of a sudden be going 10 meters per second east. Is that a change in acceleration? Yes, it is, because you have a change in direction. Okay. So keep that in mind, that when you're seeing that, just because the number doesn't change, if the direction changes, then yes, you have a change in acceleration, right? So understanding acceleration. So looking at this basketball player, the ball will be pushed out of her hand as she's dribbling. How does the speed or velocity change? So how does it change? First of all, it's in her hand. She pushes it down. What happens? It hits the floor. When it hits the floor, it's going to have a change in either probably the number. Well, it's going to definitely have a change in the speed, but it's also going to have a change in direction. Once it hits the floor, it's coming back up. Okay, the floor is actually a force that's acting upon it to change its direction, and we'll talk about that more when we start talking more about motion and getting into all the rules that there are in motion. So the speed's going to change, the magnitude's going to change. As it's going down, it's going to get faster. As the ball comes back up, what's going to happen to the magnitude of the speed? As it comes back up to your hand, it's going to start to slow down. Why? Because it has gravity acting upon it. Okay. So you have the ball going down, hitting the floor, coming back up. So you have a couple things. One, you're going to have negative acceleration, which is also known as deceleration, as it's coming back up. So you have acceleration going down to the ground. Then as the ball changes direction and comes back up, you're going to have negative acceleration. So your magnitude of speed is going to be changing. And you also had the change in direction from going down to back up. All right. So at what point does the ball have zero velocity? Okay. When does the ball have zero velocity? The only time the ball will have zero velocity is when it stops and has no direction with it at all. Okay. It could have zero speed, but still has a direction. Right. So keep that in mind. All right. And then how does the velocity of the ball change when it bounces on the floor? When it bounces on the floor, you have you're going to have a change in number in the magnitude, but you also have a change in direction. And that's what the real change is in terms of the velocity being a vector. The change in direction makes it a change in velocity. All right. So keep that in mind. You have a ball dribbling down the court. Okay. How does the speed change? The speed's going to change because as you're dribbling, you're pushing it down to the floor, back up to your hand, down to the floor, back up to your hand, down to the floor, back up to your hand. It's going to gain speed as it goes down to the floor. After it hits the floor, is coming back up, it's going to lose that speed because gravity is working on the ball itself. Okay. And it's pulling it back. And it's going to have a negative acceleration or deceleration as it starts to go up to your hand. So a positive acceleration down to the floor. As the ball hits the floor and comes back up, it's going to have a negative acceleration, which is also known as deceleration. All right. So you can feel acceleration. Okay. You can feel it. Okay. If you're in an airplane and you're moving at 500 miles per hour eastward without turbulence, there's no acceleration, right? You're going at a constant speed, at a constant rate. You're staying in the easterly direction. Everything's the same. Magnitude stays the same. Direction stays the same. So there's no acceleration that's taking place. But your velocity is 500 meters. I'm sorry, 500 miles per hour east without turbulence. Notice I said that's what my velocity is. The velocity is 500 miles per hour east without turbulence. Great job last night. They played great last night. Yeah. I am here, but I'm leaving. I have a Middle States meeting. Say it. So there would be no acceleration. But if the plane hits an air pocket and drops 500 feet in 2 seconds, that's going to be a pretty large change in acceleration. And you're going to feel that, especially if you, those of you that have been on a plane in turbulence. A lot of times, if you hit turbulence, what they'll do is they'll put the, especially with large amount of turbulence, they'll put the seatbelt signs on that you really should be wearing your seatbelt. So keep this in mind. It doesn't matter whether you speed up, slow down, change direction. It's still going to be considered a change in acceleration, right? So it can be tricky, but it's really not. As long as you keep in mind that velocity is a vector and it's got to have a number and a directional with it, you have those two things. If either one of those or both of those change, then you have a change in acceleration. Okay. So when you're looking at graphing speed and velocity, okay? So you have your y-axis is measuring your distance traveled. Your x-axis here is measuring what the time is, okay? I didn't put any numbers on it because it doesn't make any sense. But so when you have a straight line like this, okay, you have your speed is going to be increasing here, okay? But it's going to be at a constant rate. So it doesn't necessarily mean that there's acceleration taking place here. I mean, obviously there's got to be some acceleration if this is starting from a starting point, but this is a constant speed that's taking place here, okay? Then you have the time, because remember, this is distance over here. So if you have a horizontal line and it's not moving up or down the y-axis, that means your object is stopped for a short period of time, okay? And then it restarts again, but not at the same speed as it was going the first time, okay? You can see that it's going actually at a slower speed or a different speed than it was the first time, all right? So that's how you're going to read, and you always need to make sure that you're looking at the y and x axes, because that's going to tell you what's happening in the graph. It is the one thing that I've probably struggled with the most when I'm forgetting to take the detail of looking at what the axes were labeled with. Because if this is labeled with something different, if the y-axis is labeled with something different, it completely changes what the meaning of this graph means. So just keep that in mind when you're looking at it. So here we have the, I'll move this so you guys can see the whole thing. So the steepness, I hate that word, of a line on a graph is called the slope. It's the rise over run. I know you guys know that already. You've had it in math multiple years. What you need to keep in mind is the steeper the slope, the closer, when we talk about steeper, this is very steep because it's almost vertical, right? It's almost like free fall at Six Flags, right? It's very almost straight up and down. So this would be very steep. This would not be as steep. Okay. So it's not going to be as the speed's not going to be as high with this. Okay. A constant slope represents motion at a constant speed. So when you see straight lines, that means the speed is remaining the same, okay? And it's the rise over the run. As I said, the steeper the slope is, the greater the speed. A constant slope represents motion at a constant speed. So, using the points shown here, you have the rise starting here at this first point here on the line. Your rise at this point is 400. And what was the run? The run is always the x-axis. The rise is always the y-axis. The x-axis is the time. So the run is 2 minutes. So the rise is 400 meters. The run was 2 minutes. Okay. So to find the slope, what do? You divide 400 divided by 2. So the slope here is, and it's very clearly here because it's constant, is 200 meters per minute. Okay. So you see that it's 400 divided by 2. And it makes sense because if you think about it, this is probably a point right here at the 1 minute mark. It's really right at 200. So that makes sense that it's going to be 200 meters per minute. So for every minute that you do, this object is moving 200 meters. So you could figure out at 8 minutes, where's the object going to be? How far will it have traveled? It would be 1,600 meters. Okay. So you see it here. And again, you see it up here as well. It's 4 and 800. So again, it's going to be 800 divided by 4 minutes. This one would be 1,200 divided by 6 minutes. It's all 200 meters per minute across the board. Okay. That's because it's a straight line. It's going to remain constant and the speed is going to remain constant. That means there is no acceleration in a distance time graph. There is no acceleration if you see a straight line. All right. Again, looking at this, straight line means the slope and average speed or velocity are going to be the same. They're going to remain the same all the way through. Slope equals the rise over the run. Again, you're looking, it's just another way to look at this is you do the change in distance, the rise, which is the y-axis, okay, over the run, which is the x-axis. So once you do that, you'll be able to figure out, okay, here's what my slope is, and here's what I need to know, okay? All right, so straight lines mean constant. Curved lines means there is some sort of acceleration that's taking place, okay? So in this jet car displacement, you can see we start here at the position, it starts to go out, and it starts to get faster. How do you know it gets faster? Because it's not a straight line. If it was a straight line, it would be out to like, I guess it would be out to like here. But you have acceleration that's now taking place. And you can see that here, okay? So let's look at this. This rise over the run would be 5 over 15, or 5 and 15. And this would be about 750. So you could figure that the slope might be, I don't know, 750 divided by 10 would be 75, okay? 75 meters per second. But you get up here and you look at this and you're looking from the 20-second mark to the 30-second mark, you have a rise starting at 1,500 going all the way up to 3,000. So that's a 1,500 change in meters over 10 seconds. So it's 150. That's how you know the acceleration is taking place, because there's 150. This slope is 150 meters per second, whereas this slope was 75 meters per second. All right. Curves, if they're getting steeper, mean speed and velocity is increasing. If the curve flattens out or starts to descend, the velocity or speed would be doing the same thing, just the opposite. So if it flattens out, you have a negative acceleration. So if this were to suddenly flatten out, you'd have a negative acceleration. And then if it starts coming down, now you're going to have a still more negative acceleration. Well, no, you would have positive acceleration, but you would have a negative velocity. So just keep that in mind. All right. So here's just explaining it out, the two different things. All right. So that's acceleration. You're going to need to be able to understand and read the graphs. Check your axes. You have to look at these. If you don't look at these, you're not going to be able to describe what the graph is trying to describe. Okay. So I'll post this video. You are going to have an assignment. It's a virtual, no hoodies. It's a virtual lab. I will post it in your Google Classroom. I may or may not be back in time for pattern 7, but pattern 2, make sure you do report to room 103 today, please. All right, that's it. Peace.